Hello students, today we are doing physics chapter 2 motion. And we will be discussing rest, motion and motion relative and types of motion. To define rest, a body is said to be in rest if its position is fixed with respect to a fixed point or an object, whereas in the case of motion, a body is said to be in motion if its position changes with respect to time, with respect to a fixed point or an object. Now, what this means is, let's say if you have a body, let's say if you have a fixed point, let's say A is a fixed point, and you have another point, let's say B, and let's say the distance between A and B is 2 meters, and let's say I draw a graph in which here I plot the time. Let's say time is 1 second, 2 seconds, 3 seconds, 4 seconds, and let's say this is the distance. This is 1 meter, 2 meter, 3 meter and 4 meter, and this is the distance here, and time is in this direction, let's say in seconds, distance is in meters. This is 1 second, 2 second, 3 second and 4 second. And let's say I plot this. In the first second, the distance between the 2 points is 2 meters. So let's say at 1 second the distance is 2 meters. So I plot a point there. And in the next second, I see that the distance is still 2 meters. So in the next second, let's say I plot another point. In 2 seconds, the distance is 2 meters. In 3 seconds as well, the distance is 2 meters. 4 seconds as well, the distance is still 2 meters. So I get a straight line which is parallel to the time axis. And as you can see, the distance between the fixed point and another point B is not changing over time. So this will tell you that B is at rest with respect to the fixed point A. So let's say, for example, I am the fixed point and the duster in front of me is the other object, and I keep observing the duster in front of me, and as time is passing, I see the distance between the duster and me is not changing. So this means that duster is at rest with respect to me. In another example, let's talk about motion. In this case, let's say I have the fixed point A here. This is my fixed point, and let's say I have another point B, and let's say in the first second the distance is 1 meter, right? So I'll plot this in the first second, distance is, let's say, 1 meter, and I find that after another second the distance, the object B moves to another point, let's say B, and which is again another meter. So that means the total distance is 2 meters. So I can plot this here in 2 seconds, let the distance is 2 meters. And in the same way, let's say B moves to another position, let's say 1 more meter. So the distance between A and B is now 3 meters, and let me plot that. So similarly, it moves again 1 meter. In the next 4th second, it's in 1 meter, which means the total distance between A and B is 4 meters now. So you can see it generates a graph like this. So this indicates that with respect to fixed point A, B, because the distance between A and B is changing over a given given period of time, B is in motion with respect to A. So like for example, in this case, let's say the distance between the duster and, let's say B, the duster is a fixed point and I am the other object. Let's say I can see the duster in front of me, and the distance is a certain distance, and then let's say if I step away, duster is at a fixed point, but the distance between the duster and myself increased, and it is further increasing as I step away, which means with respect to the duster I am in motion. But if you think of, okay, let me talk to you about a little bit later about relative motion. But for the time being, as you understand that if A is a fixed point and B, the distance between A and B increases over time, B is in motion with respect to A. So that tells the definition that if a body is in motion, the position with respect to a fixed point object changes over time, the distance changes over time, the object is in motion. Now, rest and motion, although it appears that a body can either be in rest or either be in motion, but motion is actually relative. Now, what this means is motion depends on the observer. Observer is a person basically who is looking at the object, observing the objects, and will be able to decide whether the object is in motion or rest in relation to the observer. Let's say you have a bus and you have, let's say, two people inside the bus, and I'm saying O as the observer and let's say A is the other person. Now, if the bus is moving, despite the fact that the bus is moving, the observer will see his friend, okay, moving along with him. So that means because the distance between the observer and the next friend is not changing, so that means the observer will see that the friend is at rest. But if this observer was standing outside, okay, and looking at the friend who is in a moving bus, okay, the observer will see that the friend is moving away from him because the bus is moving along with it. So it depends on where the observer is actually observing the object from. If the observer is moving along with the object, so the observer will see that object at rest. But if the observer is in such a place where in this case the observer is outside, the observer will see the friend moving along with the bus. So here the observer will see the friend at rest, okay, but in this case the observer will see the friend in motion. Now, just for example, like if you observe the duster, the distance between duster and yourself is at rest, and in my case also, since I am standing for the duster over a period of time, the duster looks at rest. Now, supposing if I step away, so I observe the duster moving away from me because the distance between the duster and myself is increased. So I will see the duster in motion despite the fact that I am moving away, but whereas you will see the duster at rest because the distance between duster and yourself has not changed. So you will see the duster at rest, I will see the duster in motion. So it's related to the observer. You observe the duster at rest, whereas I am observing the same duster in motion because I am the one who is moving away from the duster. So that's why motion is relative. Let us now discuss the different types of motion. So the first type is translative motion. Now, translative motion is defined as if an object moves in such a way that every part of the object moves through the same distance in the same time interval. So what this means is, let's say you have an object, okay, and let me just take any 3 random points on that object and let me name it A, B and C. Now translative motion would mean that if point A travels to another point, let's say A dash, okay, or let's say over a period of time, let's say 1 second, so point B will also travel equal the same distance in the same time. So A will travel to A dash, B will travel to B dash and C will travel to C dash. So each point of this object moves to a new position in with the same distance and over a period of the same time. So this kind of motion, in which the entire object moves, in which each point moves to the next position, that kind of motion is called translative motion. So for example, this duster here, if I start from this position, if I move to the next position, so the duster has executed a translative motion. The entire duster and each and every point on this duster has moved from one position to the next. Now there are 3 types of translative motion. The first one is called rectilinear. Sorry, there are 2 types. One is rectilinear and other one I am discussing. Rectilinear translatory motion. So in this case, if motion takes place such that an object moves in a straight line path. Alright. So like if you have an object here and let's say I've got 2 points, let's say A and B, and these points moves in a straight line path. Let's say A moves to A dash and let's say B moves to B dash, and this object is in a new position and this is in a straight line path. So this is an example of rectilinear motion. Another example is, let's say if you have a ball, okay, and let's say there is a point, let's say A over here, and it drops down. So this A moves to a new position, let's say A dash, and since this ball is moving in a straight line path downward, this is also called a rectilinear translative motion. The other type is called a curvilinear, curvilinear, curvilinear translatory motion. So if the motion takes place such that the object moves in a curved line path, okay. So the difference is that both are translative motions, but one is moving in a straight line path and one is moving in a curved line path. So let's say if you take the same object and this time instead of moving straight, it moves in a curve. So you have the object moving the same distance, both the points on the object moving the same distance, let's say A dash and B dash here. So, but this path, as you can see now, is in a curve. So this object has executed a translative motion, which means that let's say a duster is here, is straight. If I move it straight like this is a translative motion and is rectilinear. But if I move in a curve this way, this object has executed a curvilinear translative motion. So this is the difference between rectilinear translative motion and a curvilinear translative motion. There are many other types of motions which we will be discussing in the next class. Thank you.